Today we're going to be talking about the product rule, and the product rule comes after finding derivatives because now we're going to have our equations look a little more complex. So notice your learning target for today that we're going to be using the product rule to apply and write equations of lines. Our end result is going to be the same as what we've done before. So here is something that you need to know. When you are finding derivatives, always, always, always power down first. If you can power down, do it. Don't do this fancy product rule if you don't have to. Don't do quotient rule that we learn tomorrow. So now the product rule says if you're multiplying two functions together. So my equation would be y equals, oops, my pen keeps moving, y equals f of x times g of x. Okay, so that's the original equation. I want you to look down here. Do you see how two things are being multiplied together? That's all it means. So my derivative is going to be, and I'm going to color code these notes. So y prime equals f g prime of x plus g f prime of x. So I said I was going to color code these. I'm going to write it out in words. From the f function, I'm going to underline it in red. So it says I take the original function. That's the first function labeled. So I'm going to say first times, and in green, I'm going to underline the g, the derivative of the second function. Oops. Let me erase that. I was going to write it out in words. So it's first derivative of the second, added on to, notice this says the second function, just the plain second function, and that's going to be times the derivative of the first. So first derivative of second plus second derivative of first. What would happen if you would reverse these two? Is 3 plus 2 the same as 2 plus 3? Yes. So as long as you have the first times the derivative of the second and add it on to the second times the derivative of the first, it works. So now, here is what we're going to do. I'm going to color code this just like I did before. So my f, oops, that was supposed to be yellow. So my f is yellow, so I'm going to write f prime here below it, f prime of x, and it's going to equal. Here we go. The red is this first parenthesis, and the pattern says just write down the first. 6x plus 5 times the derivative of that second. So now you use your little power down, and you see that that's 3x squared, and then it would be minus 0. So I am not going to write that minus 0. Add it on to the second derivative. Well, that's just, or I'm sorry, the second term is just x to the third minus 2 times the derivative of the first is just 6. Can you guys see the pattern, how I followed those words? Okay, so working this out, what would my derivative turn out to be? This 3x squared would have to be multiplied once and twice. Everything in the red gets multiplied by it, so I would get 18x to the third plus 15x squared. Added on to, same idea here, that 6 is going to be distributed to everything. So I would have 6x cubed minus 12. And that would be my derivative. Now I picked an easy one to do this first time because I wanted you to be able just to see that pattern and see the multiplication that goes throughout. So now, let's take a look at one that's going to be a little bit harder. The first thing I see is this is an r to the 1/4. So this is really g of r equals r to the 1/2 power times r squared plus 8. Okay, so following my colors like I did before, the g of r here, so g prime of r equals, first term is in red, that is r raised to the 1/2 power, times the derivative of this second thing, which would just be 2r. It's going to be added on to that second term, which is r squared plus 8. And then I'm going to take that times the derivative of the first. That is 1/2 r raised to the negative 1/2 power. Okay, so now we need to multiply this stuff together and work it out. So when I do that, I end up with y prime equals r to the 1/2 times 2r. You have to add the exponents. That's 2r to the 3/2 power. Add it on to, this r squared is going to have to be multiplied by the red, and the 8 is going to have to be multiplied by the red. So that's going to give me a 1/2 r, add the exponents. 4/2 plus -1/2 is 3/2. Add it on to 8 times 1/2 would be 4, r to the negative 1/2 power. Now, we should be cleaning that up a little bit. And when we clean that up, these are like terms. Do you see this is r to the 3/2 and this is r to the 3/2? So 2, if you need to think of 2 as 4/2 plus 1/2, that's going to give me 5/2 r to the 3/2 power. All I did is add them up. Add it on to 4 divided by r to the 1/2 power. Notice it's on the bottom because it became positive. Now, somebody's going to say, couldn't we have FOILed this and worked it out the old way? Yeah, you could have. I picked easy ones to start with, and now we're going to get to ones where you can't do anything like that. So take a look at the next example. For this next example, do you see that the first term here, that is x to the 1/2 power, and notice it had an x hooked onto it, so that's the first term. Notice the second term is a trig function. Oh my goodness, we can do this. So first term has an x, sine of x has an x. I said x twice. I am actually having to work this out. So using my colors like I did before, my derivative is going to be, the first term is x raised to the 1/2 power. It's the red stuff. Times derivative of the second. The derivative of a sine is a cosine of x. Add it on to that second term is a sine of x. And then the derivative of the first term, the 1/2 x raised to the negative 1/2 power. So clean it up. My derivative should turn out to be x to the 1/2 power cosine x. Can't do anything to that first term. Add it on to 1 sine of x over 2x to the 1/2 power. Notice this second term is the only one that has that divide by 2 stuff. So now I'm looking at this next example. Ew, this is like we did from the first chapter, or the first part. 5x squared over 4, subtract 3 over 4. This is not a product rule. It is just a plain problem like we did earlier. Oh, so when I look at that, y prime equals the 5/4 is my coefficient times 2x to the first, subtract 0, derivative of any number is 0. When I try to clean these up, hopefully you see the 2 and the 4 reduce, and my final derivative for this problem would turn out to be 5 over 2x. Okay, so looking at this one, this is not a product rule. This is an old-fashioned problem that we did last section. 3 over 10x to the negative 3 power. So my derivative, the 10 over 3 comes down, the negative 3 comes down, subtracting 1 from that would give me negative 4 power. When I look at cleaning this up, I see that there's some canceling that goes on, and my derivative turns out to be 10 over x to the 4th power. Oops. That x to the, I lost my negative sign here. I knew I was doing something goofy. My negative 10 over x to the 4th power. Okay, so one last problem to do. So this is putting it together. It says find f prime of c, so it wants me to find my derivative. At the point C, that's just saying, hey, plug in value when done. Okay, sometimes they give you a point. This is just new terminology. So first thing I have to do is I have to find my derivative. I see that it is one term times another term. If you really want to FOIL this one out, go for it. I don't want to FOIL it out. So what I'm going to do is I'm going to do my derivative formula, my product rule. And my product rule says that first term, the x squared minus 2x plus 1 is going to be plus 1 is going to be times the derivative of the second, which is just 3x squared. And I'm going to add that on to the second term, which is x to the 3rd minus 1, times the derivative of the first, which is 2x minus 2. We got a little math to do here. The x squared has to be FOILed, the 2x has to be FOILed, the 1 has to be distributed. So my derivative turns out to be 6x to the 4th power minus 2, not 2. 2 times 3 is... So let's try this again. I'm doing half of my work right away. Erase, 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 erase. Okay. X squared times 3x squared is 3x to the 4th power. Subtract 2 times 3 is 6x to the 3rd power plus 3x squared. Add it on to. This one is a true FOIL, a first, an outside, an inside, and a last. So I'm going to get a 2x to the 4th power minus a 2x to the 3rd power minus a 2x plus a 2. So now it's just a matter of combining like terms. Y prime equals 3x to the 4th and 2x to the 4th make 5x to the 4th. Negative 6x to the 3rd and negative 2x to the 3rd make 8x to the 3rd. Positive 3x squared, and there's no other x squared, so it stays 3x squared, minus 2x and plus 2. Okay, so now I have to plug in that c value. So wherever I see x, I plug in 1. So 5, oops, there's an x. I plug in 1, and I'm going to raise that to the 4th power. Subtract 8, oops, there's an x. I plug in 1, and that's going to be raised to the 3rd power. Plus 3, there's another x. Oops, it didn't change colors on me. And I plug in a 1, and that is squared. Subtract 2, there's another x. And then plus 2. Okay, so let's do the math. 5 minus 8, negative 3, plus 3 minus 2 plus 2. 5 minus 8 is 3. Negative 3. Negative 3 and 3 is 0. 0 and negative 2 is negative 2. Negative 2 and 2 is 0. My slope turned out to be 0. That is my derivative. Okay, ladies and gents, good luck on tonight, and we will talk about product rule on Monday.